Hello, now we are going to look at how to divide fractions. So we're going to start off by having 3 and dividing it by a half. So the way that we can think about this initially is how many halves would there be in 3? So if I had 12 divided by 6, what I'd be asking is how many 6s are there in 12? So we have 6 units divided by 12 units. How many times does 6 units fit into 12 units? I could also write that as a fraction, 12 divided by 6, or write it in English, 12 divided by 6. Anyway, the answer will be 2. There are 2 groups of 6 in a group of 12. Now there's a slight extra complication with fractions because we're not comparing units directly. So what we have to do is say how many halves would fit in 1 unit, and then how many units are we talking about? So we have 3 units. So how many halves would fit in 1 unit? That would be 2. 2 halves would fit in 1 unit. So I have my 3 units down here, and I would have 2 halves in each one of those units. So of my 3 units, each one of them is broken up into halves. So I have 2 halves in each unit, and then I count up and I say, well, I have 3 of those. I have 3 units. So in total, I would have 1, 2, 3, 4, 5, 6 halves in 3 units is my expectation. I'm expecting my answer to be 6. So let's look at how we can structure that. We can say how many of these, I'll write this in. So how many halves would be in 1 unit, and then we count up how many units we have. So how many halves would there be in 1 unit? Well, there would be 2 halves in 1 unit, and I'm going to write it as 2 over 1. It'll be obvious why in a minute. And then how many units do we have? Well, for each of our 3 units, we're going to have 2 halves. So we have 3 2's. So that's going to be 3 multiplied by 2 over 1. I'm going to write that as 3 over 1 as well, because we know that a whole number has a denominator of 1. And now this has become fraction multiply, because we asked ourselves the question, how many halves would fit in 1 unit? That's 2 over 1. That's 2 halves would fit in 1 unit. And then how many units do we have? Well, how many of a certain thing do we have is multiply. And we know how to multiply fractions. We just do top by top, bottom by bottom, numerator by numerator, denominator by denominator. And that gives me 6 all over 1, which we usually call 6, as expected, as our diagram indicated it should be. So that is what we have for our introduction. And this is it written out in English, the explanation and then the rule for how we're going to do this. So what we do is ask ourselves how many of the fraction we're dividing in fits into 1 unit, and then we flip it upside down, we invert it. That's effectively what happened here. You can see how many halves fit in 1 unit. That's 2 over 1. So we effectively flipped the fraction upside down. Logically, that's not what we did, but in terms of practical outcome, we end up flipping the fraction upside down to see how many of them would fit in 1 unit. And then once we know how many fit in 1 unit, we simply say, well, how many units do we have? Which is where we multiplied by the number of units that we had. And in this case, it was a whole number, but it doesn't have to be. So let's have a look at a case where it isn't. So I have 6/9 divided by a third. So let's do this out visually first. What does 6/9 look like? So this whole square here, this big square, is 1 unit this time. 6/9 would be 6 of those 9 boxes colored in. Now, 6/9 divided by 1/3. What does division mean? How many of these would fit in this? So I'm expecting, I can see that I could break this up into thirds. I could break this up into thirds. I could break that up into thirds like that. So I'd have 1/3, 2/3, 3/3. So I'm expecting that 2 of my thirds would fit in 6/9. Based on the image, I can see a third of my unit would be that, another third would be that, and then I have the last third isn't coloured in. So I'm expecting my answer to be 2. So let's use our rule now and see if we get an answer of 2 for this division. So I'm dividing by 1/3, so I ask myself how many thirds would there be in 1 unit, or structurally I just flip my fraction upside down. So how many thirds would fit in 1 unit? Well, 3/3 would fit in 1 unit, and that in effect is flipping the fraction upside down, getting its reciprocal. It's inverting it, turning it upside down, or getting its reciprocal is the maths name for it. And then I multiply top by top and bottom by bottom. I'm seeing how many of these would fit. Top by top, numerator by numerator, bottom by bottom, denominator by denominator. And I end up with 18 all over 9. And I can simplify that there's a common factor of 9 top and bottom. Or I could take out a common factor of 9. Or I could just do the division because it comes out nicely. And there are 2 of them, as I would expect from my diagram. So structurally, the fraction I'm dividing by, I flipped upside down, and then I multiplied together to see how many of these I've got based on this number of units. And in this case, this is a fraction of a unit, but we can see the structure worked out exactly the same. So let's put this into practice now with some that don't have pictures involved. I have 5/8 divided by 3/4. Now there's an important piece of notation that will be very important in the long run, which I'm going to write now. I know that 12 divided by 6 is equal to 12 over 6, written as a fraction. Well, these are fractions, but they can still be written as part of a fraction. So this question can be given to us like that. 5/8, big dividing line, divided by 3/4. This means the same thing as this, in the same way as 12 divided by 6 is equal to 12 all over 6 in a fraction. So we can see it in either way. And it's important that we are able to read something like this and be able to write something like this. 5/8 divided by 3/4. Now, what do? We know our structure is that we are going to get the reciprocal, or invert the second fraction, the fraction that we are dividing into the first fraction. The same way as we're dividing 6 into 12, we're dividing 3/4 into 5/8. How many of these fit in this? We ask ourselves how many 3/4 would fit in 1 whole, and then we see how many units we've got, how many whole units we've got. So we have 5/8, and we figure out how many 3/4 would fit in 1 unit by turning our fraction upside down. You've seen that for the whole number fractions, and you can see that it's quite intuitive. It makes sense for them. It can be harder to picture here, but we've gotten our story together by doing these simpler examples where we can see, obviously, there's going to be 3/3 in 1 whole. Well, it turns out that there's going to be 4/3 there are going to be 4 over 3 3/4 in 1 whole. So 4/3, 3/4 in 1 unit. Now that we have that, we're going to count up how many units we've got. And this time we have a fraction of a unit, but that doesn't matter. We're just going to multiply up. So top by top and bottom by bottom. We have 20 all over 24. Now this time, instead of doing divide above and below, I'm going to take out a common factor. So I have a highest common factor of 4. So I'm going to write 20 as a factor pair of 4. That's going to be 4 by 5 all over 4 by 6 for 24. And I can write that as 4 all over 4 multiplied by 5 all over 6, which is 1 multiplied by 5 over 6, which is just 5 over 6. Again, we could have divided above and below by 4, but being able to think in terms of the factors of a number is a very important skill. So here we have 4/5 divided by 12/7. Let's follow our rules. Now that we've gotten our story clear in our minds, we're going to see how many of these would fit in 1 unit by turning the fraction upside down, inverting it, or getting its reciprocal. Then it's just fraction multiply. We see how many of these we have, how many units of these. So we have top by top, bottom by bottom. And if we can see a common factor in the middle of things, that's fine. So we might do that this time. We have 4 by 7 all over the 12 has a common factor of 4. So we're going to have 5 by 4 by 3. We can rewrite this because the order of our multiplication does not matter. We can have 4 over 4 multiplied by 7 all over 5 by 3. All we've done is switch the order of multiply. 3 and the 4s like this. 4 divided by 4 is 1, and 5 multiplied by 3 is 15, so we end up with 1 multiplied by 7 all over 15, which is just 7 all over 15. And finally, if we are given mixed numbers, we know that we never do any maths directly with mixed numbers. We're always going to convert them into improper fractions and then do work as normal. So 3.5 is going to be 7 halves divided by 7 over 5. And now I'm going to write this out the other way, just so you see it again. I have 7 over 2 divided by 7 over 5 would be the other way of writing that. Now I can invert or get the reciprocal of the fraction I'm dividing by, and then count up how many units I've got. So I'm going to be multiplying. So there are 5 sevenths, 7 fifths in 1 unit, and then I see how many units I've got. And I have 7 over 2 units this time. So I multiply that up to find out how many I've got in total. So I have 7 by 5 all over 2 by 7. In this case, there's no sense in multiplying this out. I can actually see I have a nice common factor of 7. So I can reorder my multiply so that I have 7 over 7 multiplied by 5 over 2. And I end up with 1 multiplied by 5 over 2, which is 5 over 2, which I can rewrite as 2.5 as a mixed number for my final answer. This is a perfectly good answer. Sometimes we're asked to write it as a mixed number, and in that case we might do it, or we would do it if we were asked to. So that is what we need for dividing fractions. This concept of how many of the fraction we're dividing by would fit in 1 unit, and then how many units have we got would obviously be multiply. And if we can get our heads around that, then the rules for division are very straightforward. And that is what we need for now.